Afternoon, class. So I've created a arbitrary waveform generator for you guys to take a look at. The only thing is I did not implement the noise part, so on Lab 4 you can skip the noise part. The other thing is there's kind of a little bug which I haven't been able to fix. In order to actually run the program, you have to run it once and then say kill program, and it'll generate a CSV file. Now if we run it again, so this is a bug I'm trying to work on, but I've spent too much time on this, so anyways, this is a program you guys can take apart just for your own knowledge. The value 0, index 0, this is referring to analog output 0, value 1 and index 1 is referring to analog output 1. I've only shown like the first 13 numbers here of the array, but if we go in here and like we plug in 5, and we update, the analog output 0 will, not right now because I have the, here's the oscope, it's not showing anything. So first we build our wave. Let's say I want to go to index 5 and I want to make it 10 volts. So the most voltage you can go is up to 10, plus or minus 10. So let's go to index 10, we'll make that, index 10, and we'll drop it down to 5. Now, so you have to build your wave from your left to your right, and then so you go index 15 and you go 0 and you update. So then you can go minus 5, let's say, and 20, update, and then let's go minus 10 and 25. So you see what it's doing is it's applying unit steps. So whatever the last value is, everything past that, it becomes that value. I set it to only 40 points. You can go into the program and change that, and I'll show you where that is. But let's say, let's go minus 5 again. Let's go to 30. And then let's go to, let's see, 0 and 35. So one waveform we have like this. Now the neat thing about the arbitrary waveform generator is you can actually use this to generate DC values as well. So let's say we needed for some reason a minus 2 volt reference. So we can, on channel 2, let's make a channel output, analog output 1, let's make a minus 2 DC reference. So right now it's at 100 Hertz, which means this whole thing, this waveform that I've generated, will repeat at 100 Hertz. So if I apply the waveform, and I go to my oscope, we got to change the time division, and then we got to look for edge. If you look at the frequency, it's at 100. If we stop the wave, it'll stop generating it, and then we can crank this up to the max that you can figure it up is up to 5K. This is based on the number of points that I've given you guys. This number will change if you increase it. So if you increase the number of points that you want to see, you decrease your max frequency. If you decrease the number of points, you can increase your max frequency. So anyways, let's look at 1000 Hertz. And let's see, it's not triggering on a good edge, so let's increase the voltage a little bit. So there you go, there's a good edge. And then if you notice right here, channel 1 is holding steadily almost at 2 volts. I'm actually running it through a couple of op amps, so that might be a little off due to what's going on with the op amp. But every time you run this file, every time you modify the wave, it creates this CSV file. So let's go ahead and kill the program. And then if you open up this CSV file, you can open it up with Excel, but once again it's been causing little bugs with it. So if you open it up in your favorite text editor, it'll basically show you what the values are, and you can come in the text editor and edit it. The Excel one will cause it to crash, and that's another thing I haven't been able to figure out why. But what we could do is, let's say we didn't like this little let's say we wanted to just introduce a little blip here. So if I go here and I make this, let's say this is +2, and then we'll save it, close it, and then what will happen when we run the program again, it's looking in the local directory for that file, and we get the little blip now. So if we apply the wave, so you have to apply the wave to get it to generate the output. Right now it's at 100 Hertz at default, so we would have to, well, we could stop the wave and make this 1000, and there we go. So now we're picking up a little blip every 1000 Hertz, just a little tiny blip going up. So once again, if I kill the program, here I'll show you what happens if I use Excel. So if I open this up in Excel, funny thing is I can edit this first column in Excel just fine, but if I go in here, and type in -2, it'll ask me, do I really want to do this? I say save. It's asking me, you might lose some information. So when I run the program this time, it'll cause an error. The red line will disappear, and if I try to apply the wave, it'll give me an error. So basically you want to kill the program at this point, and what will happen is if you go to your, I think what you can do is open it with the text editor, and if you look in the text editor, let's go ahead and save this, and let's try running it again. So now it's working with the text editor, so what we can do now is we can update the value like we had it before, and let's say halfway we want to make it, so let's say we want to make it into a square wave, so at 20 we'll go up to 2 volts. Let's apply. So once again, it defaults at initially at 100 Hertz, so you would have to go in and change that. The frequency is not saved in the CSV file, only the what's going on with the waveform. So if I just look at basically I'm here generating a square wave and generating some sort of funky wave. So if we put the, okay, I'm going to move the oscilloscope aside, I'm going to kill program, and then if we do Control T or Command T, and I'll show you guys a little bit of the program. I won't make this video too long because like I said, I didn't actually accomplish what my task was. So the very first thing I do is I actually am seeing if the file exists in the local directory. If it exists, I'm breaking it up, I'm pulling out the 2 vectors. So these blocks right here are looking for if my temp.csv actually exists in the local directory. If it does exist in the local directory, it just splits it and writes it to the 2 vectors. This stuff right here is basically, if you look at stop wave, if I say find control, stop wave is this button, so basically when I start up, this actually gets grayed out, and the rest of the stuff is actually enabled. The reason why I want to do this is, actually everything else gets enabled over here. The reason why I want to do this is when you're using this program, if you notice when it starts up, only the things that you can edit are available. I can't go over here and hit stop wave. If it doesn't make sense, I just started it. So I can go in here and modify the values. I can modify the frequency. Then I can hit apply wave. Now when I hit apply wave like before, it started, started the my deck, and that sent it out to sent the output out, and then we're reading it on the oscilloscope. But when I hit apply wave, it changed it into a different state. So the only buttons that you can press, you can change stuff here, but that won't affect how it behaves. I didn't grade this out. I probably should have. But you can hit stop wave or kill program. So if we hit stop wave, it goes back into the applied wave state. If we apply wave, then we can kill the program at any point. Anyways, now if we go back to the block diagram, what you'll see is there's a variety of different things that I'm doing. So here I'm setting initial states for apply wave and stop wave. I'm trying to figure out what the period is just to show that so you know what it is in seconds. I've defined some user inputs here. And then what I've done here is my DAC only samples at well, basically 200 kilohertz per second. So basically, if you take the number of points here and you divide that, then that's approximately your max frequency, though it won't look so pretty. So if you wanted to improve it, you would increase this this fudge factor, and that'll kind of tell you what your max frequency is. So inside, so I have this one large while loop that's embedded. So I have this large while loop that's embedded in another while loop. There's actually 3 while loops in this whole program, but the first while loop that we run into, what it's doing is it's actually generating this wave. So basically, what these guys right here are doing is making sure I don't go over the max voltage value. And that's what this box is doing and this box is doing. So if I'm not above the max voltage, I just pass the input through. This is making sure that I'm a valid index, except I'm not looking for anything less than 0. So, well, okay, so no valid index is below 0. Sorry, I got a bit of a cold. Anyways, after that, what I do is I pass it through into here, and what I'm doing is once you've hit the update button, what it'll do is it'll basically from that point change all the values after that to be that same value. So what I'm doing is wherever, so basically I know that there's 40 points in this case, and I told it that I wanted to update here, so I subtract that, and my index I start counting from that point. So basically what it's doing, as you guys were seeing earlier in the video, is just changing the points from wherever I stopped at. And then after that, what it does is all this is doing is generating a plot that you can look at. This is creating a waveform for the my DAC, and this right here is I don't know if I really got this part working, but basically right here, this was supposed to make sure that I was within the max frequency range. But I have some little bugs here that I haven't worked out, so I decided to just submit this as an example, as I already spent too much time on this. Anyways, after I hit kill apply wave, basically what happens is I go into this next state. In the next state, I want to enable the stop wave button and turn off everything else. So if I wanted to, actually I can show you guys, so if I wanted to gray this out, what I do is you right click on what you want to gray out and you go create property node, and then you could go to disable. So I'm going to add this, go create property node, and then I'm going to disable wherever that is. Here it is. So, and then what you do is you change this to right, change this to right, and then you wire it up like so to the blue wire, and you wire it up over here. So what this does is now when I get into that state, it'll disable it. But the thing is let's say I want, because you can change what indexes you're looking at here, so I probably want to re-enable that at some point. So over here, I'll go create property node, and then I'll go disable, but I'll change this to enabled. So all these guys are connected to enabled, and I'll go ahead and do this for this guy as well. So create property node and disabled, change to right. And so what will happen, let's go ahead and run the program. Go ahead and save it. Now if I run the program, what will happen is I start out initially, everything is fine here. Let's change up this a little bit. So if I just hit update right now on update 1, it makes everything flat. So I'll do, let's say, 2 volts at index 0. So just to give you, so basically I told it at index 0 I want 2 volts, but it makes a unit step for the rest of the time. So if I go to index 5 and I say -2, it'll drop down. So if I go to index 10 and say +2, it'll continuing to do this. It'll just basically I'll just make some square wave here, and then let's say 25, and I go back to index 25 and go back to 0. So now if I apply the wave, I bring the oscope back. It's a little hard to see what's going on, but if you look at it next to this, basically, let's see if we can stop this for 1 sec. We got a single rising edge, a fall, a longer fall, and then it pops up. So that looks good. So let me continue running this and enable that. And so anyways, feel free to mess around with this program. I guess the other thing that I probably should state is, kill program. So the other thing I did, why is it not? Okay, there it goes. So the other thing I did is there's an example here of how you can write kind of a CSV file to save your stuff and how to read. And once again, what happens is, so after I generate the wave, it comes over here, I set up the clock, I start it, and then it just basically keeps running until I kill the program. The only thing I ran into is right here is where I need to introduce the noise, but it's being updated here, so I'd have to think about it quite differently. If I'm going to introduce the noise here, it'll just generate the same noise over and over again, which is not what I want, because that's not really noise. Oh, well, it is noise, but it's not random, which noise, well, noise should be random. So anyways, here is the arbitrary wave